Okay, so let's do a problem-solving overview of what we learned in the chapter. If you had a 23.5 kilogram sample of ethanol, and that is needed for a large-scale reaction, what volume in liters of ethanol should be used? And we are given that the density of ethanol is 0.789 grams per cubic centimeter. So let's start with our givens. And we know that our mass here is 23.5 kilograms. And our density is 0.789 grams per cubic centimeter. So what is our volume in liters? And again, I taught you how we can use density as a conversion factor between volume and mass. And since we're given the mass, we can start out with mass to figure out what volume is. So we can't use the conversion factor just yet because we're given our problem in kilograms. So we need to convert it to grams before we can use density as a conversion factor. So we're going from kilograms to grams. Kilograms gets a 1 because it's the bigger unit, and by a factor of 10 to the third. So now we can use density as our conversion factor. So since grams is on the top, grams is going to go on the bottom, and cubic centimeters is going to go on the top. So for every 1 cubic centimeter, there's 0.789 grams of ethanol. Now we're not done just yet because we want our answer in liters. So do we have a conversion factor from centimeters to, or cubic centimeters to liters? We don't, but we know that 1 cubic centimeter is equal to 1 mil, right? So 1 cubic centimeter for every 1 mil. And then we can go from mils to liters very easily, right? So since mils is on the top, mils is going to go on the bottom, and liters on the top. Liters is the bigger unit, so it's going to get 1, and the conversion factor is 10 to the third. And that's finally, we can stop there because we got our desired unit. You can see that your kilograms cancel, your grams cancel, your cubic centimeters cancel, your mils cancel, and you're left with liters, which is our desired unit. Another neat thing about this is if you look at it, you can simplify it some more because you have 1,000 on the top and 1,000 on the bottom. So you don't even have to plug that into your calculator. So at the end of the day, you're saying 23.5 divided by 0.789. And when we plug this in, we get 29.8 liters. So we need 29.8 liters of ethanol to do this reaction on a large scale. Okay, now go ahead and give this a try and replay the video to see if you got the answer correct. So we have a 55.9 kilogram person displaces 57.2 liters of water when submerged in a water tank. What is the density of the person in grams per cubic centimeter? So let's write our given. Our mass is 55.9 kilograms. Our volume is 57.2 liters. And so what is the density in grams per cubic centimeter? So we know that density is mass over volume. So we just plug in our values. 55.9 kilograms divided by 57.2 liters. But they want our answer in grams per cubic centimeters, not in kilograms per liter. So let us do the conversion. Let's start out with our top unit. Since kilograms is on the top, kilograms is going to go on the bottom, and grams are on the top. Kilograms is the bigger unit, so it's going to get the 1, and our conversion factor between these two is 10 to the third, or 1,000. Now we've converted the top part, so we got grams. Now let's do the bottom part, and so we can get liters into cubic centimeters. Well, we know that since liters here is on the bottom, let's put liters on the top, and our desired unit of milliliters on the bottom. And we know for every 1 liter, there's 10 to the third milliliters. And now, since we want it in cubic centimeters, remember, mils and centimeters, or in cubic centimeters, are exactly the same thing. But let's just put one more conversion factor to make sure that we got that straight. So since mils is on the bottom, we're going to put mils are on the top. And for every 1 mil, there is 1 cubic centimeters. So you see the kilograms cancel, and we're left with grams on top. The liters cancel, the milliliters cancel, and we're left with cubic centimeters on the bottom. So we have exactly what we want in the units that we want, grams per cubic centimeters. Now we do the math. And another way to simplify the math is that there's 1,000 on the top here, or 10 to the third, and 10 to the third is on the bottom, and so what's 1,000 divided by 1,000? It's 1. So you can simplify that further in your head. And you plug in the rest of the value, and you end up with a density of 0.977 grams per cubic centimeters. Now, does that sound right to you? That sounds approximately similar to the density of water, which is about 1 gram per cubic centimeter, which, if you think about it, makes sense because people are, like 83% made up of water, so they should have a similar density.